Hi there, I'm Scott Fraser, Professor of Electrical Technology, and I'm going to talk to you a little bit about our program here and the classes we have, and also going to give you a little tour of our facility where you'll be studying and working here on campus. We're on the Pacific Coast campus, and as you can see behind me, I'm standing in front of the QQ building, and this is it's right off of Walnut Avenue, and we're just north of Pacific Coast Highway on campus. So let's go on inside. Okay, I'm at the top of I'm right on the second floor where most of our electrical classes are. And I'm right here where you get out right off the elevator. And we've got a number of classrooms here, and walk around here and see the various classrooms we've got. I'm going to go down here, and the first thing we're going to see is where you'll be in Electrical 204, and that's the classrooms in here. So this is one of your classrooms. We have them all set up in here. We've got the lecture area, lab area in here. All of our labs have individual stations. We've got 120 volts, 120 208, 120 240 single phase, and 12 volt DC. And each station has their own individual circuit breaker. So if someone were to trip a breaker, it only affects that one station. And all of our rooms have emergency power offs located throughout the classroom. Just look for the red buttons. You can see another one up here. And if there's a problem, anybody has authorization to hit the red button and kill power to the whole classroom. It just affects this classroom. It doesn't affect anything else. And so you'll have both lecture and lab in this class, and all your equipment, the meters and everything. You'll find conduit boards, meters, tools, everything in here. More items in there. Okay. And each cabinet is labeled as to what's inside. So you pretty much easily look at the labels on the outside and find what it is you're looking for. Let's go on to another classroom. This is QQ 218, where you'll be for your third and fourth semester lectures. And you'll see the storage area for prints. And we've got, I believe it's 30 computers in here. And plus in the classroom, each of the lecture stations have ceiling cameras so we can look down and show things, plus wall cameras in the back there. The instructor will use those in their presentations, and we can record presentations and display them up on the big screen in each classroom. Now in here we're in QQ 208, and this is for our second semester motor and generator labs. We have these stations, and they're set up with a power supply, and then you put your motors or generators in here, your instruments up in this area, you wire everything up, and you run through and do your labs in this. You can come down here. It says First Bank. These are the DC motor or generator. They can run as both. Then we've got induction motors, there's synchronous motors, more synchronous motors, some capacitor start motors here. And down here you've got your dynamometer, so you can put a load on a motor and see how it performs under load. So this is 16 station lab, and we try and run about 25 people in here. You get kind of crowded when we max it out at 30, but it's all good. We put no more than 2 people per station, and you work on your labs there. And when you get off the elevator, right at the top here is QQ 207. That's the home of our instructional assistants, Ted and Tara. And if you're looking for assistance, they're here. We pretty much have coverage from 8 a.m. to 10 p.m. Monday through Thursday, and then evening coverage on Friday. And look down there, there's the long hall. And again, coming back, there's the elevator. And then we're going to walk into the motor control lab. This is QQ 206. And here we are. We're in for the motor control lab. And there are 30 stations. You'll do your motor control wiring, testing, troubleshooting, learn about all these things that we do. Once you get everything wired up, we go and insert faults, and then you have to try and find it. Here's one that's open, and you can see the wiring job the student did on the door. The top part, we just replaced all the PLCs in the lab, and we're going to be wiring them up. And you can, down here, and you might wonder why the controls are low on this particular box instead of that one. And this is an ADA accessible station. Okay. You see, we've got a lot. There's 30 stations in here. And here's another example of students' work. We've got their door wiring there. Everything wired up. This is wired up for a forward and reverse control of a three-phase motor. And we use the variable speed drive right here as a three-phase power source. All right, let's move on. Okay, again, as a reference spot, we're right outside the elevator. There's the hall going down. At the far end of this hall on the right is a set of stairs to go downstairs. And we have one lab downstairs for the motors and transformers. Coming down this way, got restrooms. And this door here leads to the faculty suite. You get the full-time faculty offices down here. Then you've got a stairway leading upstairs from the outside. We'll go on outside now. Now this is the yard between QQ and RR. You'll see over there on the left a pool that's for underwater robotics, all the solar panels, and right there you've got our diesel motor generator sets for a power generation program that we're just starting up. And then just right there is a traffic signal intersection. And along the side of those are the traffic signal controller cabinets. And a lot of this work we do outside. The traffic signal intersection is designed to Caltrans standards. And the only exception here is that the signal height themselves are such that you don't need to climb up on ladders to work on them. I'm going to keep you guys on the ground, and here you go. Okay. So that building that's over there to the north is building RR, and we've got a number of things going on over there, and we'll cover that next. Before we get into building RR, I made a stop downstairs at QQ, and this is our motor and transformers lab. We've got a number of stations in here. A dynamometer for running the motors and doing load tests on it. We have another dynamometer here. It's in the process of being set up. And then we've got stations with transformers. You can set up the wiring on the transformer, bring all the leads out, the terminals like this, and you make your various connections up there. Connect up a motor, connect up a load bank, whatever it is that your lab has you doing. You can see we've got a number of different size transformers in here. and each station has a metal platform on it for bolting down the motors, keeping everything secure while you're running them. These are old motor generator sets, and you can set them up, do all kinds of wiring. You can run it as a DC motor and an AC alternator, or it's AC synchronous motor and a DC generator. Now, I purposely skipped a number of classrooms upstairs. They're very similar to what we've already covered. So now I'm going to head on over. We're on the first floor of QQ right now. And at the west end of this building is a large auditorium. And you can see a little bit of thing about our electrical program playing there on the screens. See students in there working in the lab. That's 209 lab. There's the robotics lab. The robots working away, moving parts. That's where we're headed over to next. All right, now we're in RR 101, and this is where all the robotics and automation takes place. We've got robotic stations here and pick and place. So the robot will pick up parts, say off a conveyor, and move them over and put them into a pallet, run them through a vision system, do all types of checking on them, and the robots will just moving parts from point A to point B. We've got stations with 2 robots per station. We're in the process of building and designing conveyors to go from station to station. And one of the things we like to use here are these little Sun-Maid raisin boxes. They work really well because they're really hard to break. And you see somebody was pushing a little too hard on this one, okay? But like I said, they're kind of hard to break and easy to pick up. Good things for the robot to work with. Over here, we've got an underwater robot that we've taken apart, and students have restored this arm here, and they're in the process of rebuilding the other side. So we're going to have an arm on both sides, and the robot will work in this area that I'm standing in here. Got some 6-axis robots, and you can see go in there, pick up the billiard balls, rack up the balls. It's kind of not all in order right now, but you get an idea of what it can do. Somebody was working on this, and they broke the end effector on there, so that's in the process of being replaced. It's made out of plastic, 3D printed plastic, so if it hits too hard, it breaks, and we just print out a new one. Okay. Over here, you'll see our 3D printer farm, and it looks like there's a part in there that just finished printing. Let's see. Yeah. So this is a new motor mount for a pump, a hydraulic pump that'll be in a floater. I'll show you that floater in a moment. And they decided they needed to rotate the motor 90 degrees, and therefore they printed out a new mount. These are camera mounts for putting a camera in there, a little tiny camera, and then it'll be sealed and go underwater. Okay. Now over here is our hydraulics and pneumatics area. These are hydraulics workstations. The students will work on these for 8 weeks in the hydraulics and pneumatics class. And then on the back side, we've got pneumatics workstations that they will also work on. So you have 8 weeks of pneumatics and 8 weeks of hydraulics in this class. Now, one of the things we do is all this robotics and electrical and automation. we have students work on underwater robots each year. Okay, and I was just showing you the motor mount. You can see that part there. And that motor mount is going to go and rotate that pump 90 degrees so that the input and output goes up and down rather than sideways. So this is an autonomous floater. It's designed by the students, and it will go up and down the water column and survey the take sensor readings as it goes up and down the water column. There's a circuit board the students built, has a Bluetooth antenna, Bluetooth module there, and then down here you'll see a power supply module also built by the students. Okay. And this will hold a bladder, and it's called this portion here is the buoyancy engine. As it sucks water in from outside, it'll go down. If it pumps water out, buoyancy will increase and it will float back up to the top. All done without any connection to the outside world. Over here is their underwater robot they're working on. This is the electronics module. You can see that there. And they're in the process of designing a new front, designing a gripper, and a new side for these. This side here will replace these sides that are on there currently. And all that work, we need equipment, and you can see we've got a number of pieces of equipment here for our fabrication lab, and we're just cutting parts. Let's see, day before Christmas, so they're in the process of doing it, still need to do a little cleanup. But this is a CNC lathe, and this was donated to us by Track Machine Tools, Southwestern Industries, and we've got another one down at the end. Got a small machine right here. And we've got a knee mill. And over here we've got the large 4-axis mill in there. CNC router. Cutting out the frames. And of course we've got buffers, grinders, drill press, chop saws. Pretty much anything you need to make anything robotic, along with those 3D parts. Okay, we are back in the lab. And that's about it. So, welcome to the electrical program. We hope you're going to have a lot of fun here, setting yourself up for a great career for the future. A few things about this. I went through this program myself when I got out of high school. Did it in 2 years during the daytime, full time, and I went out and got myself a job working in the field, making of today's equivalent about $36 an hour to start. And you can do the same thing now. We've got people looking for our students, and we put you all to work. So walk around the labs. When you come here, get yourself comfortable with where you'll be studying, and we'll see you in class.